Hello everyone, I'm Frank and welcome to Learn How to Sudoku, where we take a very easy variant Sudoku puzzle and we break it down in detail so that you can learn how to Sudoku. Today's very easy puzzle is called SVS number 460, Index Lines by Richard. And here are the rules. Apply classic Sudoku rules, which means in every cell in the grid, place a single digit such that every row, column, and designated 9-cell region contains the digits 1 through 9 exactly once each. On an index line, the digit in the nth cell along the line, starting from the diamond, indicates the position along the line where the digit n appears. For example, 3, 2, 1. Oh, that's too few. Okay, well, let's do this one. 3, 2, 1, 4 would be a valid line. The first digit, 3, indicates that the third digit is a 1. The 2 in the second spot indicates that the second digit is 2. The 1 in the 1 in the third position means 3 has to be in the first spot, which it is. And the 4 in the fourth position means 4 has to be in the fourth spot, which it is. Right. And you cannot have something that goes off the end, right? So you can't have, say, this be 9 here, because that's saying 1 has to be in the 9th spot, but there is no 9th spot on this index line here. Obviously, if you had 9 digits, you could have used that, but that's a separate issue. Anyways, those are all the rules. If you like to play along, there's going to be a link in the description. And now, I'm going to get started. Let's learn how to Sudoku. Okay, so as I was saying, on the index lines, you can never reference a position that the index line doesn't have. So that means on an index line, first of all, you can only have the digits from 1 to the length of the line, right? Because if you can't reference something outside of the line, which would be, so in this case, it would be size 6. That means you can never have 7, 8, or 9 on it, right? Because you can't get to a 9th position, you can't get to an 8th position, or a 7th position. So that means in this index, well, first of all, this would be 1 through 4. Also, another thing about index lines, you cannot have repeats. If you have a repeat, what is that saying? Say you had a 2 here and a 2 here. That's saying 1 has to be in the second position, but 6 also has to be in the second position, and therefore that doesn't work. So therefore you cannot have repeats ever along an index line either. That means these digits are 1 through 4, because that's the length of the index line. These digits, because of the 1, 2, 3, 4 quadruple in the box, you cannot have 1 through 4 here. This is at most 6. So this has to be 5 and 6 here. This is 1, 2, 3, 4, 5, 6, 7, 8 in length. So this can be, it cannot have 1 through 4, cannot have 5 and 6 because of 1, 2, 3, 4 quadruple and the 5, 6 pair in the box. This has to be 7 and 8, which means where's 9 in the box? 9 has to be here. Well, this is saying 5, 3, and 4 have to be in the 5th and the 6th spot. So this must be a 3, 4 pair, which means where are 1 and 2 on this index line? They have to be here because you can't have repeats. Because you can't have repeats, you have to have every unique digit on the index line. And this 1, 2 pair eliminates 1 and 2 in the rest of the column, so this can't be 1, 2. This is 3, 4 as a pair in this box, which eliminates 3, 4 in the rest of the box. 2 cannot be in the first position, so 2 has to be in the 4th position. So this is 4, which makes that 2, which makes that 1, which makes that 3. 4 eliminates 4 here, so that's 3 and 4. That means 3 is, that's saying 6 has to be in the 3rd position. So this is 6, and that's 5. Okay, this is 7 and 8 here, which means 1 and 2 must be in the 7th and 8th position. So this is 1 and 2. 1 eliminates 1 here, so that's 2, which makes this 1. This is saying 8 has to be in the first position, so this is 8, and 7 has to be in the second position, so that's 7. These digits must be 1 through 5. That's the length of this line. No 1 or 2 here. This 1, 2, 3, 4 triplet or quadruplet eliminates 1, 2, 3, 4 here. So this is 5, which is 5, not 4. How do I get 4? 5, which is saying 2 has to be in the fifth position. So this is 2, which eliminates 2 and 5 on the rest of the index line. And that's fine there. Remaining digits on this index line are 3, 4, 5, 6. This cannot be 3 or 4, so that's 5 or 6. So that's saying 6 has to be in the fifth or sixth position, so that eliminates 6 from being here. 4 here eliminates 4 here. 3 here eliminates 3 here. This is saying, so 6 is one of these two. This is saying 3 has to be either in the third position or the fifth position, which is valid right now. 4 is in the fourth position or fifth position, which is valid here. Okay, so this is also the digits 1 through 8 because it's size 8. This is 1 through 7 because we have 7 on this index line. So we have 1 through 8, 1 through 7, no 1 or 2 here because of the 1, 2 pair, no 3, 4, 5 here because, or 8 because of 3, 4, 5, and 8 in the column. No 5, 6, 7 here because of 5, 6, and 7 in the column. No 1 through 5 here. No 4 or 7 here. No 1, 2, 3, 6 here. And no 2 or 4 here. So that should limit quite a few things. So this is saying 1 has to be in the 6th, 7th, or 8th spots. It cannot be in 6 or 7, so it must be in the 8th spot, which eliminates 8 from the rest of the index line. And it's saying 1 has to be in the 8th position, so this is 1. Well, this is saying 2 has to be in the 4th, 5th, or 7th positions. It cannot be in 5th or 7th because of the 1, 2 pair in the box, so it must be in the 4th position. So that means this is 2. And that eliminates 2 and 4 on the rest of this index line. That means this can't be 4. This is 3, which is saying 7 had to be in the third position. So this is 7 here, which means this can't be 7. This is 6. Therefore, that leaves that as a 5. So we can't have 2 and 7 here. This 4 eliminates 4 here. This can't be 1, 3, 5, or 6. That leaves a 4 there. So that's saying 7 has to be in the 4th spot. So this is 7, which eliminates 7 here. So that's 6, which is saying 3 has to be in the 6th spot. So this is 3. So no more 3, 4, 6 here. No 3, 6. No 3, 6. 2 eliminates 2 here. So that's 1, which makes 2 there. 1 is in the first spot, 2 is in the second spot. 3 eliminates 3 being here. So where is 3 on this index line? It must be here, which is saying 1 has to be in the third spot. So this is 1, and that's 4. Okay. Remaining digits of row 5. We have 7 and 9. This can't be 7 because of 7 in the box, so this is 9. That's 7. Remaining digits of row 6. We have 5, 8, and 9. And this can't be 8 or 9, so it's 5, which makes this an 8 and 9 pair here. This 5 eliminates 5 from the rest of the box, so this is 1, 2 as a pair, which means where is 5 on this index line? It has to be here. So that's 5. That makes this a 3. That means the remaining digits in row 4 are 5 and 6. Okay. Where is 7 in this lower central box? Cannot be here because of 7 in the row. Can't be here because of 7 in the column. That leaves a 7 there. We have 4, 8, and 9 remaining. 4 cannot be here because of 4 in the column. So 4 has to be here, and that leaves this as an 8, 9 pair. And that leaves that digit as a 2. Remaining digits in column 4, we have 8 and 6. So this is 6 or 8, 6 or 8. Column 5 has 7 and 9. Okay. Column 2, we have 1, 2, 8, 9 remaining. This cannot be 2 because of 2 in the column. No 1, no 2. Remaining digits of column 3. We have 1, 5, 6, 9. And this cannot be 1, 5, or 6, so that forces this to be 9, which means this can't be 9 here. So that's 1, 5, 6 triplets, which eliminates 1, 5, and 6 in the rest of the box. So no 1 here, no 1 here. This makes an 8, 9 pair in column 2, which eliminates 8 and 9 in the rest of the column. This can't be 8 or 9, it's 2, which means this can't be 2, it's 1, which makes that 2. So this is saying 1 has to be in the second position, and 2 has to be in the first position, which is valid. Remaining digits in this upper left-hand box are 3, 4, and 5. Not 5. 3, 4, and 7. This can't be 4. No 3 here. One of these is 3, so this can't be 3 here. Whereas 3 in this box, it has to be here. Remaining digits in column 1. We have 3 in the corner. We celebrate because we're nowhere close to solving this. We have 1, 6, and 8. This can't be 1 or 6 because of 1 or 6 in the row. So this is 8. This can't be 1 or 8, so this is 6, which makes this 1. Remaining digits in row 9 are 2 and 7. 2 can't be here because of 2 in the column, so this is 7, which makes that 2. 1 eliminates 1 from being here. 5 eliminates 5 from being there. Remaining digits of row 7. We have 3, 6, 8, and 9. This can't be 3 because of 3 in the column. We are guaranteed a 6 here, so this cannot be 6. And that's it. Remaining digits of row 8. We have 4, 5, 8, 9, and this can't be 4 because of 4 in the column. Okay. Where is 7 in row 1? Cannot be here. Can't be here because of 7 in the column, so 7 has to be here. That leaves this as 1, 6, 8, or 9. Cannot be 6 because one of these is guaranteed to be 6 here. Remaining digits in upper right-hand box. Well, let's just do column 7. We have 3, 5, 6, 8, 9. No 3 here. That's all we have restricted. Column 8. We have 4, 5, 6, 8, 9. 4 cannot be here because one of these is guaranteed to be a 4. And where is 1 in row 3? Cannot be here because 1's in this box and the line doesn't work here. The index line already has a 1. And this 1 eliminates 1 from being here. 1 can't be here, so 1 has to be here. So this is 1, which makes that 6, which makes that 5. 6 eliminates 6 here, so that's 8 and 9. 9 eliminates 9 here, so it's 8, which makes that 6. So no 6 or 8 here. This can't be 6. Where is 6 on this index line? It must be here. So this is 6, which makes this 5, which makes this 9. 5 eliminates 5 here, so that's 4. 9 eliminates 9 here, so it's 7 and 9. 7 eliminates 7 here, so it's 4 and 7. This can't be 8 or 9, it's 1. 3, 5 as a pair eliminates 3 and 5 in the rest of the box. This can't be 5 or 9, it's 6 or 8. This is 6 or 8. It can't be 6 because of 6 in the column. So this must be 8, which makes that 6. 8 eliminates 8 here, so it's 9 and 8. No 8, 9 here, so that must be 3. 3 eliminates 3 here, so that's 5 and 3, which is saying 3 has to be in the third spot, 4th is in the 4th spot, 5 is in the 5th spot, 6 is in the 6th spot. This can't be 5, 8, or 9, it's 4. This can't be 3, 6, or 8, it's 9, which makes this 8, which makes that 9. This can't be 8 and 9 here, so this is 5. 8, 9 eliminates 8 and 9 here, so it's 6, which makes this an 8. And that's how you solve it. Yep, fairly straightforward. I hope it made sense how I was attacking these index lines, because it's pretty not pretty limiting, but because you can do a lot of things with index lines as a setter. So I guess it's really not that limiting. And there's a lot of interesting things you can do with it. So anyways, I hope you enjoyed this episode of Learn How to Sudoku, and I'll see you next time on Frank Puzzles. Take care.